Our new topic is continuation of the previous topic. In previous topic, we tried to control a drive by using commands from HMI. We had indication clues for the operator on the HMI. Now we design a faceplate for one drive. And the next step will be create a function block for several drives and the faceplate for several drives. But in this example, we just focus controlling one drive by using the faceplate. The previous topic, this is the link for the previous topic. I will provide the link, and you can see that in the previous program we had the start, stop, and acknowledge buttons to control this drive. In the this topic, we will encapsulate all of these commands in a faceplate. Faceplate makes commands for similar devices, reusable in HMI level for several cases in the same project or for the future projects. So this is the previous, it is the same previous program. We have fault monitoring. We run the drive here and we report to the HMI when the motor is run. We report the status with with one signal. When it's a stop, we report it with 2, and when it's faulty, we report that with 3. So we need to add the HMI to our project. So the HMI, you should select the PLC first. There's a wizard to complete the project for you. You can select the wizard to add a root screen for you and provide some basic designs for you. The first step in order to create a faceplate, we can go and create a new screen. In the new screen, this is the new screen. We should insert a rectangle. It's possible to change the background color. It's possible to change the background color to white. And the next step is to add some buttons here. This is the first button. We can consider it to adjust the size. This is the start button. Start button. Rename the start button in the MISC start B_BT start _BT, and we need a stop. This is the stop button. Stop, right click, stop button. Acknowledge is the next button. Rename it here. The label should be renamed and add the name of the button. ACK _button. We need to add another small button at the top. We limit to X. and adjust the size here. So see, it's like somehow like a closing button here. Let me rename close underline button BT. So the next step will be adding the drive from elements from the library. You can, if you want to change the drive or blur, you can go to general, change the category from here and select your proper element in the lab in that category. We are happy with this blur. It's possible to adjust the size and click save now. And it's possible to rename. It's not important to rename this because it's unique. It's unique. Okay, and we select the whole assembly here and right click, create, select create faceplate. And the name of type should be drive underline faceplate. This is the first version. You can comment, and we will move to the faceplate editor. In this editor, we can create some properties for the faceplate. For the properties, we can create a category. For the category, we can edit. This is the category for main elements. In the main elements, we have the start underline CMD, and the signal is integer. So again, we have another property, and it's stop underline CMD. It's Boolean again. We have another property. It's acknowledge underline CMD, ACK underline CMD, and the tag is integer. Sorry, Boolean. The acknowledge is Boolean. The next is status. It's integer. It's okay. And the final property is visibility. Visibility is Boolean. So all properties are created. We need a binary signal to control the starting command. We need a stopping command. We need an acknowledge command. We need to read the status of the drive from the PLC, and we need internal memory for visibility control. Visibility control, I will show you. It should be used for all elements. Visibility control should be used for all elements. So first we need to map the signals with the properties or events from this table. We should map some properties and events with these properties of the faceplates, or externally they are tags from the PLC. So first I start with the start command. I go to properties. In the event, I have the option For press I set bit. What bit I should the bit is related to a start command. First I set the start command, and when I release the button, I reset the same command, reset the same signal. So we save, and again we go to the next signal. This is the stop command. When we press, we set bit, set bit. Which bit should be set? The bit related to the stop signal. For releasing, also reset bit, stop command, save. And the final is the acknowledgement. When we press, we need to set something. The set signal is acknowledge command, and when we release, we need to reset acknowledgement. Okay. And this is the visibility control. For buttons, we need to check the visibility when the visibility signal visibility signal is true. When the visibility signal is true, we have the permission to show these signals. This button is also linked to the visibility. When this signal is true, we have the permission to show, and the same is applied for acknowledgement. Should go to the visibility. When visibility is true, it's possible for us to show these buttons, and these are background, white background or white rectangle is also it also has the same property for being visible. This button is also the same visibility condition. When visibility signal is true, we can see that, and this is the final element to define the visibility. If the visibility signal is true, it's possible to see this element. So we have done the important part in this. While pressing this button, this is the closing button, we should go to event, and in case of pressing, we need to reset the visibility. It's closing the faceplate. We should reset the visibility. In the main page, when pressing the element, we should make it this signal true, and in the faceplate, by clicking this button, it will be closed. If you have 10 drives, you need to define encapsulated data that is connected to PLC, and one signal for visibility of faceplate related to each drive. The final point is defining the properties. Transparent is in background, okay. We need to select the shaded here. In flashing, it's possible to select the gray here, and I think we are done in animation. We should go to overview. We need to dynamize color. The tag related to dynamic color change is the status. When the status is 1, we need to have the green color. When the status is 2, we need to have the red. And when it's 3, we need to have the flashing status. Gray and yellow, you can change this color, and the flashing should be true. So then you finish this this list. You can see that the connections are already made between the properties of these elements, generic elements, and the signals that should be fed or should be provided from the PLC. So I press release this version. This is the newer version, so we can use that in the in our project. So in order to go to the our TIA Portal project, you should select the start, as you can see here. Now we can delete this screen, as we have the faceplate in our library, project library. So I insert the faceplate here. I adjust the size, and now I can insert something else here from toolbox. I add another blur here. The blur is consider the blur should be clicked. You should click on the blur or drive to make the faceplate visible. For that, we need to turn on the visibility. Before that, we need to connect. We just state we need to connect the signals that are related to this faceplate to the PLC signals. I have the acknowledge. For the acknowledge, I can go to the PLC tags and select the acknowledge here. For a start command, I go to the PLC and select the set. For a status, I should go to the and we have this only one integer here. For a stop command, we should go and select the reset signal, and for visibility, we have a visibility signal in PLC. It's a bit difficult to handle, but in the next video I will show you how to encapsulate all data from PLC and make the data interface of data much easier. This will be our future topic. So we made the connection. Now it's possible for us to run the in advance, turn on the visibility. We set the visibility by clicking this drive, and then we have the faceplate. We can change the we can do our task here and then finally close. Select the HMI. We should go online. For us, it's possible to select. It's possible to stop and start again. I wanted this. I need to check the background. I will try to have this background, and you can see that it's possible to fetch the or run or see the faceplate, start, stop, close, and it's possible for us to generate the we have this problem for the for blinking. We should go to the library, edit the type, in edit additions. Let me first check the animation related to that, visibility. This it was the problem first here for the background, and again for our drive. We should go in the properties. Visibility is okay. We want to check the status, yes. And what about the properties? Flashing. Let me change these colors. Release the version and update instance in project. So when you update it, it's automatically updated with the available version in the program. So we select the HMI and go online again. So we have the background, we have the blinking, and acknowledge. We start again, we close, it's started. Now we can stop, we can start again, and we can simulate a fault. Fault is simulated, the drive is off, and we need to remove the cause of fault. Acknowledge, start. So you see how to create a very simple faceplate. This is the very basic version. I will tell you how to develop a complex function block and use the same scenario to create function block and use it 10 times and use a reusable faceplate with some tags here. This will be our next video, and I hope you find something new here. It's a very simple project to understand the dynamic, and I will provide the most practical project in the next topic. Thank you for watching, and please subscribe to our YouTube channel.